Hi, thank you for choosing this video to watch. I wanted to show you a couple things. I've been playing around with these equalizers, hooking them into my synthesizer, and they make some interesting sounds. So I'm going to play those for you. First, if you're not familiar with an equalizer, it's basically just a big filter. You can filter out the low end or filter out the high end or any one of these frequencies. I'll focus in on these sliders and show you what exactly I mean. First, I want to give a brief demonstration of what an equalizer does and what hertz is. So this is the equalizer that you just saw. This is a function generator that will generate the frequencies that this manipulates, and this is a little oscilloscope that will show the frequencies. Hopefully I'll be able to focus in on it as I twiddle the knobs. So let's zoom in. So this is going to be a silent demonstration, except for my voice. Each one of these little sliders is designated with a tiny little number here. You can't see it. Maybe I'll do a close-up right there. So the first one is 31 hertz, and I've dialed in 31 hertz on this function generator, and you can see the line here is fairly flat, but it's still picking up a slight sine wave. But when I turn up the slider, the amplitude of that sine wave increases. And you can see it up here too. There's the amplitude. And it's also kind of leaking through onto the 62 hertz. So if I turn up the 62 hertz, you can see there's a little bit of amplitude increase there, but not very much. So this just controls, if I play with any one of these other faders, it doesn't do anything on this oscilloscope screen because this one fader only controls that frequency of sound. And if I wanted to, let's say 125 hertz, I'm just going to nudge myself in here, 125 hertz. So now when I play with this fader, it doesn't do anything. But if I go over to the 125 hertz fader, there we go. So this is just dialing in. This is just, it's filtering out everything else but 125 hertz. Any sound that you play through this, all the other frequencies will be filtered out except for this one frequency here. You'll notice that as I change the amplitude of this signal, I'm not changing the frequency of the signal, meaning that the amplitude is how much space this little sine wave takes up vertically, and the frequency is how much space it takes up horizontally. We measure a sine wave, let's say that the center of it is right here, where the pink thing is. We would measure the sine wave beginning here, down to the bottom, and back up there. That's one cycle. 1 cycle per second is 1 hertz. 125 cycles per second is 125 hertz, which is what you're seeing now. I have this set up down here so that it's visually pleasing for the camera. If I had it set up to read 125 cycles per second, what you'd see is, let's say one of these little segments is a second, you'd see 125 little cycles, little wiggles between this and here on each one of these. This little oscilloscope doesn't have the resolution to show something like that. But conceivably, if you had a really nice oscilloscope or one that you could dial in and change the views on, then that's what you would see. So this is to say that this is not a picture of a sound wave that we see. We would not see this in the air. This is a little electronic device that graphs sound in this way so that we can measure it in a standard fashion, so that we can look at the top and bottom of this sine wave and say, yes, that covers the space that it needs to cover, and that's what I wanted. So I'm going to move over here to a picture and talk more about that.
Now, I don't want to belabor the point about this silly little graph, but it is what most people visualize when you talk about a sound wave. They picture a nice, smooth little wave in the ocean. But what's really happening is, if I had a little button and I pushed it, it would make a sound like this. Right? And what that sound does is it vibrates a little membrane inside your speaker, which compresses and decompresses the air. I'm visualizing that with these little dots. Again, a little visualization. But if you happen to have a little microphone on the other side of the room, that microphone has a membrane inside it too, which would be excited by the compression and decompression. That would translate it to an electronic signal, which goes to your recording device, and it's interpreted as sound. So these areas of compression, which happen more or less frequently and with more or less force, according to the pitch and volume of the sound, get translated through the microphone to voltages, higher or lower voltages that happen more or less frequently. And that's what this graph represents. It represents the frequency and amplitude of the voltages that were created by the compression of the air. Now, this is, in human terms, what happens when you speak and the sound enters your ear through the canal and into your brain. And I'm sure you know this, but inside the ear are little hairs that translate the compression of air into little electronic signals, much like in the microphone, which translates the compression of the air into electronic signals, sending it to your recording device, which is our brain. Now your big brain knows what I'm doing when I'm playing with a frequency on this little equalizer. So now let's return to me in mid-sentence talking about where you can get this equalizer and what I'm going to do with it.
But people don't usually use it anymore because they just listen to their music on their phone or on the computer, unless they're stereo files. So I got these for free, but if you want to mess around with it too, you can probably find it online for 12 to 50 bucks. Or these are just like sort of old ones from the 90s, late 80s.
Higher quality ones are more expensive, but you'll get the same effect. So let me show you.
So these are made by two different brands. Onkyo's known as the better brand. Optimus was the Radio Shack brand, but this one has more features, and I think it sounds better. I think this one was built as, or marketed as part of a whole stereo system, so they just sort of made a basic model. So you can see that this one, the lowest band width that this will separate out is 6.3 hertz, and the highest is 1600 hertz. On this one, the lowest band is 3.1 hertz. Is that focusing? And the highest is 1600. So obviously there's two controls for two channels, the left and the right, for stereo use. What I decided to do was separate out each channel for itself, because this modular system is mono anyway. Well, most of it is. And so that means I can pipe one mixer out into the back to the left side, and the other mixer out onto the right side, and I can play around with the mix. Or I can choose any one of these components and pipe it out into one side or the other. Also, let's look in the back. You can see the main has an input and an output. I have this one going out to my mixer, which is going out to my speakers. And the input has two different channels, left and the right, and that is being broken out on a little board I have made down here. I'll show you that in a second. But I also just wanted to show you that there are two other sections here, tape 1 and tape 2. So there's two more inputs on each one of these that I can pipe any component into. I could not play them all at once though, because tape 1 and tape 2 are switched. So I can either play these two, or those two. But it's still kind of interesting. It's kind of like a mixer and an equalizer. Just to show you this upstairs one. See, this one only has the main in and out, and then tape 1. So right here is the breakout board that I made out of it's just an aluminum panel that I found. It's scrap aluminum. This is the out that goes up to the in of the equalizer. One of these cords goes to one mixer, and the other one I have right now plugged into the Make Noise Ocoast. So just so I can have two very different sounds that I can play with and make it obvious that these are different. So on the back you can see that it's just very simple. I've just connected the stereo jack to two separate mono jacks on either side, and then for these RCA jacks I've broken them out to two 3.5 millimeter mono jacks. So it's the same thing. Very simple wiring. Okay, so just a little demonstration. The left channel is the Ocoast, and the right channel is the modular system that I have set up. So I'll just do a little selection. The Ocoast has high tones, so this will emphasize the highs. It doesn't actually have any low tones, so there's nothing really there to hear. You can do a band pass. And here's the right side. Now both. Now here's something really interesting about this one. This one doesn't have these extra features. This one has, let me get up closer to show you. These buttons, basically, in this one bypasses so that there's none of this is affecting the sound. And the same thing happens with record. It bypasses the sound unless you're recording. But this one's very interesting to me. It kind of inspired me. It's called Image Enhancer. Obviously, it's not an image because it's sound, and it's not that image because that is an image, but it's a fancy word that stereophiles use to describe the way you feel about the sound that you're hearing. It's an image you have in your mind, but it's an audio image. But it does enhance that image, don't you think? And what I was thinking was, this is very much like a resonance knob, but it's just a switch. It's a resonance switch. It's basically feeding the
qualities of these frequencies that you've turned up back in and amplifying them, making them more enhanced. Basically, that is the same as what's happening over here. It's like this resonance knob, or this resonance knob. And basically, on this filter, you turn it all the way down here and it's filtering out one band, and this side will filter out the other band. I think this is the high and this is the low. And well, that'll be future videos. But basically, why not do that over here? Why not put a little knob up here that controls a circuit that feeds all of the signals coming from these highest points, feed them back through the circuit and amplify them, so that I can do the same thing here as I'm doing here. So what I did was I went online and I bought the service manual. Not to Onkyo, I went to eBay, and you know there are people who collect manuals for everything from old electronic components and will sell them to you for a price, which is fair, I guess. If you want it, then you should buy it. But if you're not familiar, a service manual is different from the owner's manual, which we get in our box, and it tells us how to, you know, operate these little switches to make the sound come out. Service manual tells you what's on the inside, and really useful block diagram of how the sound enters and how it exits. And there's a little diagram of the PCB itself with all of the components listed here and the numbers printed on the PCB. And then the most invaluable thing for me was the schematic drawing and all the numbers that correspond. So with my meager knowledge of filters and how the resonance circuit fits in with the filters, I basically saw this as one big filter, the in and the out, and where a resonance circuit could be fitted. This is my little drawing. I'm not going to show you it all because it's embarrassing. It doesn't actually work. I kind of gave up after I did some real shoddy hack work. Basically trying to replicate a resonance circuit, connecting it from the input of one op amp and the output of the other op amp, so that it would feed through around from the filter back around and feed back into the filter. This did not work, and also I realized as I was poking around that the only way for me to really determine whether this was doing what it needed to do, I had a little oscilloscope hooked up to it, but I would need to have it turned on and actually touch points from here to there until I found the right combination. And this is plugged into mains, and I'm comfortable playing around with 9-volt batteries, but I don't feel comfortable putting my body near that much voltage or current, really. So I gave up on this, and I'm going to play it the way it is. So for the rest of this video, I'm just going to play that as if it were a little filter, and then encourage you to go ahead and try it yourself.